Hello everyone, it's February 23rd. Let's get this party going. Maybe some tree again. Could be. Alright, most profitable path in tree. Here is a undirected tree with n nodes labeled 0 to n minus 1. Rooted as 0, you are given a 2-integer array edges of length n minus 1, indicate there is an edge between A and B. At every node, there is a gate. You are also given an array of even integers. Amount, where amount I represents the price needed to open the gate, and node I, if it is negative, or the cash reward obtained and opened, but unopened the gate otherwise, right? The game goes as follows. Initially, Alice is at 0, and Bob is at Bob. At every second, Alice and Bob each move to an adjacent node. Alice moves towards some leaf node, while Bob moves towards node 0. For every node along their path, Alice and Bob either spend money to open the gate at that node or accept the reward. Note that if the gate is already open, no price will be required, nor will there be any cash reward. If Alice and Bob reach the node simultaneously, share the price for opening the gate. In other words, if the price to open the gate is C, then both of them pay C divided by 2, and they will be rewarded by half as well. If Alice reaches a leaf node, she stops moving. Similarly, if Bob reaches node 0, he stops moving. Note that these events are independent of each other. To the maximum net income Alice can have if she travels towards the optimal leaf node. Very complex problem. Okay, so we have the tree, right? And then Alice starts from 0 and going down towards the leaf. Bob start with 3. Alice initially at 0, Bob at 3. They open a gate of the respective. Alice net income. Okay, you can do negative. Alright, so you do negative. And Bob is also negative, right? Bob and Bob just doesn't matter, right? Bob does not matter. We don't really care about Bob. Bob can do whatever. And Bob can go like back and forth as well. But Bob's goal is just to go towards 0. So basically, for each node that is positive, we don't want Bob to hit there. But if a node is negative, we kind of want Bob to hit there because you can reduce the amount of cash to pay, right? And Alice and Bob move toward node 1. So they reach the simultaneous, they open the gate together. Actually, oh wait, hold a second. They all have to move, right? So Alice moves down. Bob has to move up. So there's no way for Bob to move down as well. Okay, so Bob has to move up. And it's a tree. So Bob actually only has one way to go, right? Yeah, I think Bob has only one way to go. Because it's a tree. Like what else can Bob do? It's a tree. So Bob only has one way to go, which means we already know along the way which node Bob will hit. So for Alice, it's basically we're gonna just DFS Alice And as we DFS Alice, we keep track of where Bob is. Like just steps, right? It just steps. So yeah, we start from the start and then we move, right? We move and Bob will move as well. You know what? I think we should try Bob first. We go from Bob, go all the way back towards the root, right? Towards the root, and towards the root. So for Bob, Bob needs its own graph. All right, Bob needs its own graph. Like it's kind of a reverse. So Alice has a graph and Bob has a graph. So Bob's graph, we will go and we'll record number of steps, like when does Bob reach each node, right? So in this case, we have 0 is -2, 1 is 4, 2 is 2, 3 is 4, 4 is 6, right? So Bob starts from here, and my bad, it's -4. And it doesn't matter. Doesn't matter what Bob is. So start from here. So this one. So step 0, right? At step 0. So say Bob reaches at step 0, and Bob reached this at step 1. Bob reached here at step 2. Okay, so Bob will reach these positions at these steps, and now you go from Alice, from this going down, right? So when it starts, Alice will have step 0, and then you see Bob reached this at step 2, so there's nothing. So you have to take -2, and then go here is step 1. And you see Bob has here step 1, so you can +2 because we shared. And then you can basically, we can go here, step 2, and Bob is now here, so you just +2. So that's it. This is n will be 4. Or you go here, step 2. Bob was here step 0, so you don't get penalty. So now you keep going. So basic is this, and then you +6. So and the end, the result is 6. Right? So in this case, Bob is at here. So again, the same thing. So we have node 0 is whatever gigantic number, and node 1 is whatever number. So Bob will start here. So at step 0, right? Bob is here. And then at step 1, Bob is here. So we note when Bob reaches these positions. Now Alice starts from here. So Alice is 0. It's smaller than Bob. So Alice has to take the full penalty. And coming here, step 1, Alice is larger than, which means we don't get a reward. So the answer is just this. Okay, let's see. I'm not very happy or comfortable with the idea that we have to create basically two graphs. I wonder if one will suffice, but if it's one, how do you decide? Right? How do you decide when someone reaches where? I mean, I can go through all the paths, right? I can go through all the paths, like position 0, position 1, position 0, 1, 2, 3. I can get everything, and then one of those will be Bob, right? And then I can rework it so we can get a Bob's path, and then for each and every other path I have to check with Bob, right? I have to check and then basically recompute. I wonder if that is a better solution. Or we just, you know, do the graph. See, I don't even know, because this is saying A and B has an edge. That's it. That's all it tells us. Right? It doesn't really say it's a 1 to 2 or 2 to 1. It doesn't really matter because we go from 0, 0 to 1, right? And then from 1, don't the zeros have 2 and 3? So for 3, as yep, and I can use that to traverse, so I don't really need a reverse edge. But if I want to go reverse, or think of as 3 as the start, we think as this is the start, and we will DFS, well, it will go on one side, it will also go the other side. So all we want is to find the path that hits 0, right? We just want to find a path that hits 0. Once we find a path that hits 0, we'll record the path, right? We'll record the path and record the node. I mean, think about it. We can get all the paths out. Right? We get all the paths. I don't know. Oh, we go from 3 and towards 0. Levels. Levels. Yeah, that is, it should be, we use BFS, right? BFS for Bob, because for Bob, we don't really care exactly which node it lands on. I just wish to know at what step it can reach where. I mean, there is only one path for Bob to go. There is only one path for Bob to go, but which path is it? We'll have 2 paths, or maybe more, but one of them is going up. The other might go down to the See, that is the part I do not know. Because, let me think again. Okay, let's just do DFS from 0 coming down. Okay. Or we can do BFS, doesn't matter. Right, so have one layer and then we have second layer. And now we need a path. We need a path. So yeah, we got all the paths. Okay, we got all the paths from 0 towards the end, and one of them will have Bob in it. Right, one of them will have Bob in it. One of them will have Bob in it, and we recognize which one that has Bob in it. Then we take that one. Right, when we take that one, take the one that Bob's in it, we also need to know at what position it is, right? Then we can get, yeah, so we need to know the level. So if we go, 0, 1, 2, right, when we get that, so we know Bob is in path index this, okay? We have a path index, and we have its the levels. So there's a level 2, so that path index whatever, level 2, that's where Bob is. And then we can kind of count him back, so we know no. Now we just go to that specific path. We do the Bob thing, right? So we say we can get a map to say at position 3, right? Bob is at step 0. At position 1, Bob is step 1. At position 0, Bob is at step 2. So we can do that, and then and then you go through everybody else, and then you do it one more time. I'm not sure. I wonder. But we don't know, right? That's the only way we know. Hold on, let me think again. So like if we have these, then we go through every single one. Oh, then some paths will be counted twice. Okay, how about we first round DFS, we just find Bob. Once we find Bob, we unwind, right? We'll unwind, then we create this, okay? Then we DFS again, and this time is Alice. And as we go through, we have to go to the leaf for every single one, and then we find the result. Okay, that seems to be more likely, but we do need a graph, so I need a map, actually unordered map, right? And here is gonna be a vector, right? So this will be a graph, and for int I, we can say auto e of edges, say graph e0, right, dot pushback e1, graph e1, pushback e0. Okay, So that is to get a graph done. Next, we need to know std unordered map int bob steps. Okay. Then we have a function. Let's call it private void get bob steps. Then for this one, we need unordered map int. Oh my goodness. Alright, so we need a graph. Then we need a current node. And then we need bob steps. Then we need, that's it. And I realize this has to return an int. It will return the steps, right? Oh, I also need to know bob. Int bob. So if node is equal to bob, okay, node is equal to bob, then bob steps node shall equal to 0. Right? It will equal to 0. We can return true or false. That probably is a better way. That's alright. And then we'll return 0. Right? So basically this is done. Just we return the current level, right? And then we know the node will be at this level. So if the node is equal to Bob, then we do that. And if node is not equal to Bob, then we will have to go say for int child of graph node, right? Int child of a graph node and level, right? Next level try equal to get bob steps, and we do graph child. Ooh, hold a second. If child is equal to parent, then we shall continue. Yeah, we need a parent as well. So int node parent. Okay. So yeah, so we get the node, so the child, node, Bob steps, and Bob, right? And we say if next, oof, right? And we say if next level is large or equal to 0. Okay. If that happens, then we say Bob steps node, right? Which means the node gets visited, shall equal to next level plus 1, and we return the Bob steps node, right? That's essentially what it is. If it's smaller than 0, then that just means it doesn't work, right? And we just keep going, keep going, keep going, and then we'll return -1, right? That's not working. Okay, so this is to get Bob levels, and we can say get Bob steps. We'll get graph node. It was gonna start with Bob. No, start with 0, right? Parent is -1, Bob steps, and then Bob itself. Right, so we have Bob steps. Next will be, what's the next? void, right? No, it's gonna be int get Alice profit, max profit. Again, we'll do the another map. Graph node parent. We don't need Bob step. We don't need any of those. We need Bob step. Bob steps. Okay, right? And then basically, I'm at myself, so I need to go through everybody. Right, I go through everybody. Oh, and my current level. Right, node parent steps. Right. Okay. So what I do is I go through everything. I go through all my children. They'll give me the biggest value, and then I just find the biggest value. Okay, that's essentially what it is. So I'm at node, and I will find out how much I can get. Oh my goodness, how much I can get? Jesus. Amount. Okay, so I'm at node, and so int total, what I can get, also current shall equal to is node in Bob steps. So basically, if your steps is smaller than Bob's step, right? Then, if you're smaller than Bob's step, then Bob hasn't reached you, so you take the full. Okay, so I think I need to say I have my current step, I have Bob's step, so Bob's step, so BS is Bob's step, should be Bob's steps dot get. I'm not sure. I think should be Bob steps dot contains node. Right, if it contains node, then just Bob steps node. If it does not contain node, then we get a gigantic value. Okay, so we can say int max. Right, this is the Bob step, and then the current. Right, current will equal to your current steps if it's smaller than Bob's step. Okay. If it's smaller than Bob's step, then you get the amount node. You get a full, right? Otherwise, if it's equal to Bob's step, then you get amount node divided by 2. Or you are larger than Bob's step, then you get 0. Right, so this is the current, and then you will go through, so you can say next, so current, what is the price or the profit, right? So max, so next profit, max profit go to int minimum, and I'll say for child of graph node. If child is equal to parent, then we'll continue. Otherwise, next max profit should be the maximum. Next max profit and get Alice next profit. Then we'll put graph child node steps plus 1, Bob steps and amount. Right, you just get a maximum for this, and then you do all that. Then you can return. And remember, once you get next maximum profit. Oh, it depends, right? So return next max profit. If it's larger than int min, right? If it's larger than that, then you do current profit plus next maximum profit. Otherwise, you just do current profit. Okay, so with that, so we get the Bob, and then we can basically return get Alice next profit. So we'll get the graph. The start with 0, -1. Steps will start with 0. The Bob steps, and then we do amount. Okay. Just give this a shot, see how it goes. Not sure. It looks alright. I guess it will work. Bob's path is deterministic because there is only one way, right, to go from any node back to the root. We can find that path and record at which step Bob reaches which node. Then we try all possible routes for Alice and take into consideration Bob's position when Alice reaches each node. This adjusts Alice's profit. Yeah, this adjusts Alice's profit. We find the max profit Alice can accumulate among all the paths she can take. So I think it's ON because this essentially is 2 rounds of DFS. We visit every single path exactly once, right? Yeah, I think this is ON. Okay, let's try to see if it works. Might not be the best implementation. I feel a little bit disconnected. So we'll see. We'll see how this one goes. Okay, we got it, but not the best runtime, but it's all right. 238, 33%. All right, let's see. What's the editorial? DFS and BFS. So we find Bob, we find Alice. Alice has multiple choice. That's true. Yep, yep, you can do that. Yes, yes, exactly. Yep. It'll be pretty long, I know. Yep, this is the tree. What is tree? I don't know. It suddenly has this variable. Maybe it was defined somewhere else. Yeah, it's defined here. It doesn't use a map. It's alright. Find Bob path. Okay, find Bob path. What do we get? Bob path. Yep, exactly how we expected. Find Bob path. And then we do that. Source, Get a time, yes. Income. Node Q front 2, 0, 1, 2. Ooh, that was nice. Now let's do just node first. Yes. Yes. And let's do the same time, yes. Otherwise it'll be the full. Go to the next one, keep going. And you need to put the maximum. Exactly, you put the maximum. Or yeah, if Alice does not reaches after, then you don't add anything, and you get this one. You put this. Keep going. You get that. That's exactly the same. Okay, that is exactly the same. This is the one that we use. 2DFS. This causes redundancy, as each node may be visited twice. Yes. Instead, we can optimize by combining both tasks into a single traversal, ensuring that we only explore each node once. Our strategy is to use DFS to simultaneously track Bob's path and compute Alice's best possible income. How do we do that? We first establish Bob's travel time to each node. We initialize all node distance to n, a value greater than any possible travel time. Tree. If a node is part of Bob's path to 0, we update its distance, reflect how long it takes Bob to reach it. Nodes not on Bob's path retain their initial value, ensuring that they are always considered as being reached after Alice. With Bob's travel time recorded, we can now determine how much Alice collects from each node with recursively traversing the tree. As Alice moves, we compare. How is this different? Well, let's see. We build this distance from Bob. Wait, what's distance from Bob? It's distance from Bob. And then we find path. We have source node, parent node, time, Bob, and amount. Oh. So this is define a distance. Else, source node is not equal to Bob, then the distance is n. What is n? N is amount dot size. And then we go to children. Max child. And distance from Bob equal to minimum distance from Bob plus adjacent plus 1. Distance from Bob is the minimum distance from source node. Oh yeah, and then if Alice reaches node first, distance from Bob. Oh, I handle the children first. And then I handle the current. Max income plus equal to max income. Max child. So we get the distance from Bob as well. So if distance from Bob larger than this, we'll get a full amount. Which at the same time, otherwise I don't do it. If max child is equal to int minimum, which means we don't have any, so we return this. Otherwise we return this. So we basically, it's this exact same idea, but we use a technique that's similar to what I'm doing, but instead of doing it in 2 times, this get Bob step can be achieved in the same run as this. We just set distance to Bob, right, everybody, and then if it's 0, then distance to Bob becomes 0, right, and then we will handle it afterwards, so we don't have to do 2 traversals. Okay, yeah. I think it makes sense because of recursion, right? So when you hit the current, you don't know, right? We don't know where the Bob is, so I just keep traversing everybody, and then it will tell me after we traverse everybody. Now we tell me if what the position Bob is, and then you can. Yep, that's single traversal is good. Oh, now I'll slide. All right, that will be it. I'll see you guys tomorrow. Adios.